Hey guys, this is Elizabeth Unseld, your instructor for CIS 141. Welcome to week 2. Before we get started, just a couple housekeeping things. At this point, you've gone over the syllabus and you've passed the syllabus quiz. Continue to reference this if you need it in the future. The syllabus will keep you informed of the expectations of the course, and don't forget about the course calendar, which will keep you in line with where we are throughout the course and throughout the semester. The next thing, announcements. Make sure you're keeping an eye out for announcements and reading them thoroughly when they come out. They will tell you what's going on and if any changes have happened or any information that needs to be presented to you outside of the lecture and the course material. Third, the weekly folder. Please make sure you're reviewing the weekly folder every week so that you can see the lectures when they are made available. If we have any extra credit or assignments where you can get extra points, they will be listed there for the corresponding week. And any additional information like links to interesting articles or videos will be posted in the corresponding week folder as well. The next thing, SAMS projects. Sometime this week, which is the second week of the course, your account for your SAMS project should be activated, meaning you should be able to follow the instructions in the video that you've seen and go ahead and log in and get started on your projects if you like. The assignments, although they should all be available, they're not all due at the same time, so they're staggered. So all of the different types of projects will be due at the same time. All of the PowerPoint projects will be due simultaneously. All of the Word will be due at another time, and then all of the Excel. And there is no need to purchase anything. Like I said before, the university is providing your access, so you shouldn't be required to buy anything else. If this changes, I'll let you know. The last thing, the drop date to drop this course with a W is October the 14th. So as we move through the material and move through the course, if you find that you're not enjoying or you're uncomfortable with the format, or you just prefer to have a face-to-face course, keep this date in mind. So, now that we've gone over the basics and the housekeeping things, let's go on and get into the meat and potatoes of the course. This week we'll be going over Chapter 1, which pretty much is an introduction to the world of computers. This is going to give you the foundations for the rest of the course. So this will be a fairly long lecture, although the chapter in itself is pretty, easy to understand. It's only about 30 or so pages, so make sure that you are also following up these lectures by reading through the material in the book. So let's get started. So some of the learning objectives that you'll go through this course in this chapter. We're going to learn about why it's essential to learn about computers today. We're going to talk about ways that computers have been integrated into our business and personal lives. We're going to talk about a computer and describe its primary functions and operations. We're going to look at some of the important computer evolution milestones. We're going to identify major parts of personal computers. We'll look at software and understand how it's used to instruct the computer. We'll also list types of computers and then talk about some examples of each. We'll explain the difference between a network, the internet, and the web. We'll look at accessing a web page, and then we'll also look at and discuss the societal impacts of computers. Overview. For this chapter, these are the items we're going to look at. What computers are and how they work. We're going to discuss computer terminology. We're going to get an overview of the history of computers, the basic types of computers in use today, how to access resources on the internet, and societal impacts of computers. Why do we even need to bother learning about computers? Over the past 20 years or so, computers have become so ubiquitous in our daily lives. They've become an integral part of everything that we do now. From accessing our media, from entertainment, productivity, so on and so forth. This is known as pervasive computing. Now, there is a difference between having a solid basic computer literacy and just being able to pick up a cell phone or an iPad and place a call or watch a video or play a game. That's what we are going to tackle in this course. We're going to give you the tools so that you can understand what a computer is and how it works, in addition to being able to pick up the easiest pieces of technology. Hopefully after this course, you will have a better understanding and confidence in your ability to access and use computers to their fullest potentials. So let's take a look and go back to before computers became the biggest part of everything that we do and integrated into everything that we do. So before 1980, computers were large and expensive. Very few people had access to them, and they were mostly used for high volume processing tasks. So prior to 1980, most of the people that used computers were business people, educators doing research, and the computers are used for high volume tasks such as sending out and processing bills, looking at inventories and keeping track of inventories. Now, after the 1980s is when microcomputers came along. That made computers inexpensive so that the masses could get them. Well, maybe not the massive, but some people could get access to them. Computer use increased dramatically. And this is a very short, very high level of how computers have evolved. We'll get more into that shortly. So today, nearly 90% of U.S. households have a computer. And the majority of people use computers at work. Electronic devices are converging into single units with multiple capabilities. So on your television, you can check your email, you can watch just television shows that you've recorded or stream live, you can view internet content on your cell phones, and you can do all of these same tasks in multiple ways on multiple devices. Computer literacy is an essential skill so that you can easily pick up these skills and be able to convert them from system to system. So today, when you're using your computer, aside from checking emails, you use them for a variety of tasks. Looking up information and news, exchanging emails, shopping and bill paying, watching TV, downloading music, and the list goes on and on. What other things can you use your computer for? What do you do on your computer at home? Do you use them for reference and productivity in addition to entertainment? Of course we do. So some of the other things that we'll look at that are related to this, we'll need to look at wireless networking. That way you can use your computer from anywhere. Do you have Wi-Fi in your home? What about your appliances? Can you access your phone and use it to control your garage door? Or what about your shopping list? How do you know if you're low on milk or you need eggs? That's where some of these things come from with our traditional appliances having built-in computer or communication technology. And this translates into smart homes. Hopefully in the future, even now, common household tasks are going to be monitored and controlled by just one central computer in the household. So this is where things like the Apple Smart Home, Google Nest products, all of these things will become more and more ubiquitous and integrated into our daily lives. Next, let's look at computers in education. And just like you guys, youths today have been inundated with computers. So in addition to having them in their classrooms, they are also born with parents who are looking up information about the stages of birth on their smartphones. They're looking up baby names and they're ordering baby products over the internet from places like Amazon and the websites of these stores. So from the time that they're born, they're exposed to computers. There are baby games and apps on the iPad and smartphones. And then when they get into class, as opposed to when I was coming up and there may have been one or two computers in the principal's office, they have computer labs everywhere. Now, everybody's using computers on the job. Previously, when we talked about computers first coming out, they were reserved for researchers and for people with very highly sets of specific computer-related skills. Lots of education. Researchers, the people that were running the companies. Now it's a universal tool for decision making, productivity, and communication. All levels and types of employees use them. They're used for different things as far as access control and other security measures. Professionals use them. They're used in the armed forces, and they require skills to be refreshed constantly because it's ever changing. Everything is getting smaller and faster and easier. So aside from the simple things being easier to use, you'll need to refresh your knowledge because someone will have to develop these programs and someone will have to train others on how to use them. Let's talk about computers on the go. In nearly every aspect of daily life, you will encounter computers. Can you think of some of the places where you encounter them just walking through campus? Consumer kiosk. So this is where if you were in an airport or on campus per se, and there's a vending machine. Well, now the vending machines are more than just putting $1 or some change in. Now they're linked via internet to your, so they can see how many big red dollars you've got, or however form and method of payment you're using. It's not just dollars and cents. ATM locations. Point of sale systems at retail stores, so checkout counters. And now they're being replaced with iPads, if you've noticed, in some locations. Self-checkout systems. Consumer authentication systems. And again, the list goes on and on. So now let's look at what a computer actually is and what it typically does. By definition, a computer is a programmable electronic device that accepts data, performs operations on that data, and stores the data. The basic operations of a computer include input, processing, output, storage, and communications. So if you look at these four laptops on your screen, you can see where the input is entering data into the system. The processing is where an operation is performed on that data. So let's say that we've got a computer that's going to add numbers. So it's going to add 2 and 5. So that's the processing part. Output is presenting the results. So in this third screen, you can see that it has output the number 7, which is the result of where it has processed, adding 2 plus 5. Storage is saving that data or anything in a program for output for future use. And the communication includes sending or receiving the data. So looking at this image or this set of images, think about how you interact with computers. Not just a laptop, but again, ATMs or your iPad or even your smartphone. And just think about the basic operations and how this cycle unfolds when you're calling up a program or even making a cell phone call or performing basic calculations. It's the same concept. Now let's look at data versus information. So what is data? Data is just the raw, unorganized facts. It can be sent in text, graphics, audio, or video. So let's say that you've got just a random set of numbers. Well, that's all that is data. It's just the random numbers or shapes or any kind of figures or any kind of just raw data. To turn that into information, that data has to be processed into a meaningful form. So then if we take those figures that we discussed, that raw data, and we create a chart, or we label it and we process it, we can go from a set of heights of all of your classmates to then we can organize it into something that says, the average height of the student in CIS 141 is 5'8" or 5'9". And so from then we can use that data to make meaningful decisions. So computing or converting raw data into meaningful information can take quite a while if you do it manually or by hand without the help of computers. And we briefly discussed how prior to 1980 and the advent of a more affordable personal computer, that usually computers were used for big tasks in large corporations and used by engineers and educators with specific skills. So let's look at them now. The computer as we know it today is a fairly recent invention. Again, the early 1980s, early 1990s is when we've seen it just explode and become, again, more ubiquitous, more integrated in everything that we do as it is today. The history of computers is often referred to in terms of generations. Each new generation has a major technological development. Pre-computers and early computers, let's say before 1946. Abacus, slide rule, and mechanical calculator. Raise your hand if you know what any of those are. What about a punch card and a tabulating machine or a sorter? Another thing about refreshing your knowledge and keeping your knowledge up to date is because some of these terms, some of you may have never heard of, but before the computers that we know today, these were the mainstream. These were the iPads or the iPhones. So let's look at the first generation. So these were computers from 1946 to 1947. They were large. They were powered by something called vacuum tubes, which kind of look like light bulbs. So these vacuum tubes and these computers, they used a great deal of electricity, generated a lot of heat. They were large and they took up a lot of space. That's why you didn't see them in many companies. Just in the more advanced companies and industries where they were doing a lot of heavy research and a lot of calculations. The first two supercomputers, or old school first generation computers, were called ENIAC and UNIVAC. And I'll let you read more about those in the chapter. Moving on to the second generation, we'll classify this as 1958 to 1963. So the second generation is when we started to see transistors. We found that computers were smaller, more powerful, more affordable, more reliable, and more energy efficient. So there, between the first and second generations, pretty much what happens is what happens now. Computers get smaller, computers get faster. And so we'll skip ahead to what we know as computers as of today. We're currently in what we are calling the fifth generation of computers. Although we're in the early stages, we're looking at computers that may be based on artificial intelligence. These computers are using voice and touch inputs. These computers can be based on optical computers, and they are starting to utilize nanotechnology. So these computers are so much more advanced than the computers of the prior first, second, third, and even the fourth generation. So now let's talk about hardware. Hardware is the physical part of a computer. The internal hardware is located inside of the main box or the unit of the computer. External hardware is located outside the system. It connects to the computer via wire or wireless connections. Hardware devices are associated with all five of the computer operations. So going back to the input and the processing. So let's look at input devices. What would you use to input information into a computer? Keyboards, mice, cameras, fingerprint readers. Now let's look at processing devices. They're used to perform calculations and control the computer's operation. So now these, again, they're going to be internal to the computer. But when you're thinking about the computer and how it performs things, you want to think about what hardware it uses. We call this the CPU, or the central processing unit, and the memory. So sometimes you will hear of the central processing unit being referred to as the chip, or the brain of the computer. So that's what we're talking about there. And then memory, or you've heard of memory sticks, or and we'll get into RAM and DRAM in other courses if you continue on with CIS. Output devices. They're used to present the results to the user. So they're presented in, again, a myriad of ways. Monitors, printers, speakers, so on. Next, other pieces of computer hardware include storage devices. These are used to store the data or access the data from storage media. These can include hard drives, CD and DVD discs, and disk drives and USB flash drives. Okay, extra credit to the first 3 people to send me a picture of a floppy disk to my email. If you don't know it, look it up on the syllabus. Other hardware includes communication devices. This will allow the users to communicate with others and to electronically access the information. So this can include modems, network adapters, routers. These things helped us connect to and access the internet. Software. Software, in actuality, is not tangible. So even though it may come on a tangible device, it's actually the program or instructions used to tell the computer hardware what to do. System software can include operating systems that start up and control the computer and its operations. And without the operation system, the computer cannot function. So this boots the computer and launches programs at the user's direction. Most use a GUI or GUI, which is a graphical user interface, to interact with the user via icons, buttons, tiles, etc. System software includes Windows, Mac OS, Linux, and Android, among others. Now let's talk about application software. Application software performs specific tasks or applications. So that lets you use Excel to create a budget, or a word processing software to create and send letters, inventory software to help manage your inventory and customer databases, photo editing software to edit pictures, scheduling appointments using scheduling software, and again, the list goes on. We've basically touched on what computers are. Now let's talk about who uses computers. Everybody, yes, I know. But typically when we're referring to computer users, we're talking about the end user. So these are the people who use the computer to obtain information. Computer professionals can include programmers. They write programs. System analysts. They design the computer programs. And then computer operations professionals that manage the day-to-day computer operations, and security specialists. These are the people that secure the computers and their networks against hackers. Let's talk about the 6 basic types of computers. We've got embedded computers, mobile devices, personal computers, servers, mainframe computers, supercomputers. Embedded computers are embedded into a product and designed to perform specific tasks or functions for that product. Typically, they can't be used as general purpose computers, and they are often embedded into household appliances, thermostats, sewing machines, treadmills, answering machines, cars. Some of the embedded computers in a car, for example, would be the computers that control your lane departure devices so that it beeps and kind of takes back control of the car when you're departing your lane, or it alerts you if something is coming at you in your blind spot. Mobile devices are small devices with some type of built-in computing or internet and communications type of capability. So these will have a small screen and keyboard. They can include smartphones, handheld gaming devices like your PSP or Game Boy, portable digital media players, and your media tablets. Now let's look at the personal computer. It's a small computer to be used by one person at a time. So probably the computer that you're on now would be considered a personal computer. It's also called a microcomputer. It's available in different sizes and different shapes. These computers are primarily used on or stored next to a desk. So they can include tower cases, where the portion of the computer that holds the software that kind of does the processing can either sit next to the monitor or it can sit on the floor. They have a desktop case, or they can be an all-in-one like the new iMacs, PC or Macintosh, and they primarily are not portable. So you're not going to pick these up and take them with you when you go camping. Portable computers, however, are designed specifically to be carried around easily. They are fully functional computers. They can either be notebook, which we call laptop computers. Typically, they use a clamshell design, or there are tablet computers. Normally, these are the type that use a stylus or touchscreen. They have no physical keyboard typically with them, although you can buy add-on cases. And then there are hybrid notebook tablet designs, maybe like something like the Lenovo, where you can have it either use it as a laptop, fold the screen, and then you can use it as a tablet. Now, netbooks typically are smaller and they have more limited features than conventional notebooks. Thin client and internet appliances. A thin client is used to utilize a network for much of its processing. Typically, they have a lower cost, increased security, and easier maintenance. They have limited or no local storage, and they're not able to function as a computer if the network is down. So these are the computers where you typically are only accessing the internet. Internet appliances, they have a specialized network computer designed for internet access. So some of these apps deliver the news, sports, weather, music, and other web-based information. Now let's discuss servers. The server is a medium-sized computer, and it's typically used to host programs and data for a small network. So users will connect via a network with a computer, thin client, or a dumb terminal. Virtualization. This is where you create a virtual rather than an actual environment, and typically you use this to share the server for increased efficiency. Mainframe computers. If you've ever heard of someone talk about a mainframe, they're usually talking about a powerful computer where typically large organizations are using these. They use them to manage large amounts of centralized data. It's a standardized choice for places like hospitals, universities, large businesses, and government offices. And typically these are located in a climate-controlled data center where the rest of the company will connect via a network. These are large, very expensive, and more powerful than servers. And usually they operate, or they're needed to operate 24 hours a day. Now let's discuss supercomputers. Like a mainframe, they are fast, expensive, and very powerful. Typically, again, large corporations doing lots of research, are going to use these. Typically, they run one program at a time as fast as possible. Supercomputers can cost several millions of dollars. And they tend to be very large and contain a large number of CPUs, or central processing units. Titan is one of the fastest computers currently in the world. Let's discuss computer networks and the internet. A computer network is a collection of hardware and other devices that are connected together. These allow users to share hardware, software, and data, and they can communicate with one another. Network servers manage the resources on a network. Computer networks can exist in many sizes and types. You can have a small home network. School and small offices will typically have a network. Large corporations will have bigger networks. And then there's also public wireless networks. What are the internet and the World Wide Web? Well, the internet is the largest, most well-known computer network in the world. Typically, people will connect using an ISP. This is an internet service provider. The World Wide Web is a resource. It's just a vast collection of web pages available through the internet. So typically, you will access the internet and you will access the World Wide Web through the internet. When you're connecting to the internet, typically you will need a modem or a network adapter. Networks can sometimes require a username and password, so your protected home internet connection and the internet connection on campus you'll have to access using username and password. Internet connections can be direct connections where they're always on. So this would be T1, or a very high-speed connection. So the computers on campus typically will have a direct connection. Dial-up connections. We typically don't use these anymore. That used to be where you would use your phone line to connect, and internet addresses are used to access resources on the internet. You use Internet Protocol, or IP addresses. It's a numeric address that identifies computers. Typically, your IP addresses are numeric and they are unique, so no two will have the same. Your domain names correspond to the IP addresses, and there are top-level domains, and then these identify the type of organization or its location. So, for example, your .com is a commercial business, .edu, those are educational institutions, and .gov are government organizations. These are the most widely known and used. And as you see in the image to the right, there are several others. URLs uniquely identify a web page. They include the protocol or the standard being used, the web server that's hosting the page, the names of the folder in which the web file that you're viewing is being stored, and the web page. Now let's talk about email addresses. Email addresses typically consist of three components. There's the username, which is the identifying name. Then there's the @ symbol. And lastly, there's the domain name of the computer that's handling your person's email server. So for example, I am Elizabeth.Unseld at wku.edu. Let's talk about surfing the web. Typically, you use a web browser to display web pages. Examples of these would be Internet Explorer, Firefox, etc. Your browser starting page is your home page. It's the first page that is displayed when your browser is open. To navigate to a web page, you can type in a URL in the address bar. You can click a hyperlink, which is graphics or text linked to the other web pages. Or you can select your link from a favorites or a bookmark, or even a page from your history list. Finally, let's talk a little bit about computers in society. As you know, the vast improvements in technology over the past 10 years have had a distinct impact on daily life, at home and at work. You cannot mention an aspect of life that has not been touched, either made better or worse through the advancements that we've made. Some of the benefits of a computer-oriented society include the ability to design products before construction, leading to safer products, earlier medical diagnosis and more effective treatment, devices that allow physically or visually challenged individuals to perform job tasks, documents can be emailed or faxed in moments, and finally, downloaded information. This includes movies, music, programs, and more on demand at the touch of a button. For all the benefits of a computer-oriented society, there are also risks. Some of these risks include stress and health concerns, spam, computer viruses and malware, identity theft and phishing, and privacy issues. Some of these privacy issues can include how data is collected and how secure that collected data is, how safely it's stored, where it's stored, who has access to it, and what is done with it after it's been collected. So the next time you use your computer to surf or to access your banking information, to send and receive email, please take into consideration some of these things when you are going about your day-to-day life and your day-to-day business online. Lastly, let's talk a little bit about the differences in online communications versus traditional communications. You may have noticed that it's less formal talking via text or in an email versus being in front of somebody face-to-face or even on the telephone. You'll notice that there's a completely different etiquette or set of rules. Traditionally, we like to be polite and considerate of others. We'd like to refrain from offensive remarks and being aware of abbreviations and emoticons that are used in online or electronic communication versus traditional communications. Acronyms such as BTW or text talk, as you may call it now, are vastly used. Illustrations such as faces and emoticons are also more widely used now. Completely in place of words, you will now see several different pictures to portray how somebody's feeling and what they're trying to communicate. So there you have it. That is Chapter 1, An Introduction to the World of Computers, in a nutshell. Again, this has been a broad overview of the Introduction Chapter 1 because I expect that you will go in and read the text yourself. Like I said, there's fewer pages in the text than there are in the slides of this presentation. So hopefully you'll go in and review those. Please remember to email me if you have any questions and to use CIS 141 in the subject heading. Again, in most cases I can get back in touch with you within 24 hours, but if you do not have that subject in the subject line of your email, it may take longer. And I was serious about the first 3 people to give me a picture of a floppy drive. You will get extra credit. Let me know if you have any questions. Thank you.